back with another video on linear equations part 2. Let's dive in. Okay, so let's recap. First of all, go and watch part 1 if you haven't already. And if you have already seen part 1, let's recap a little bit. So in part 1, we learned that linear equations are fundamental mathematical expressions that describe the relationship between variables in a linear manner. So when we say linear equations, first thing you should always know that linear means where the degree of is 1, right? So these equations would be of the form ax plus b is equal to 0, this form. Now when we talk about what we're talking about in this chapter is linear equations in two variables which are written as ax plus by plus c is equal to 0. Two variables, you must understand there are two variables x and y, and we'll be solving this. In the previous video, we solved these equations and we got three cases there. First, where the lines were intersecting, so this would be the solution. In the second one, the lines were coincident, that meant they were lying on top of each other, so this had infinite many solutions. And in the third part, the lines were parallel, so they had zero solutions or no solution. And we also studied about the ratio of the constants, right? When a1 upon a2 is not equal to b1 upon b2, then we have intersecting lines and exactly one solution. When all the three ratios are equal, we have coincident lines and there are infinitely many solutions. And when a1 upon a2 and b1 upon b2 are equal, but they're not equal to c1 upon c2, then we have parallel lines and no solution. That means zero solutions. And if this was also equal to, then obviously they would be coincident lines and they would have infinite many solutions, right? So remember that. Now moving on, let's study the algebraic method of solving a linear equations. Okay, so algebraic method has only two parts. One is the substitution and the other is elimination. These are the only two that we have to learn. So let's start with the first one, substitution method. So let's take an example to understand better. The first equation that we have is equation, let's name it 1, that is 7x minus 15y is equal to 2, and equation 2 is x plus 2y is equal to 3. Now with the word substitution, you must understand that what we have to do is we have to take out the value of 1 and then substitute into the other one, right? So in these two equations, you can pick any equation, but I would suggest you pick the one which has smaller constants, like it has 1 and 2 and here it is 7 and 15. So I would choose the second equation, right? So we pick the second equation, which is x is equal to 3 minus 2y, right? And in this, we would substitute, we would take out the value of x, which we have already taken out, that is x is equal to 3 minus 2y, and we substitute this in equation 1 in place of x. That we do 7, it used to be x in equation, now it is 3 minus 2y minus 15y is equal to 2. Now this becomes a linear equation in one variable, which is very easy to solve, right? Then after solving this, we get y is equal to 19 upon 29, right? So now we can solve this in three ways. Either you put this y in equation 1, or you put this y in equation 2, or you put this y in equation 3, right, which we made. So whichever you find easy, you will get the value of x in all three ways. But I would suggest you pick this one, because in this, when you put the value of y, it would exactly give us the value of x. So now x is equal to 3 minus 2 multiplied by this, the value of y, right? So this gives us the value of x as 49 upon 29. Now this, you can also do it other way. Now that we've calculated the value of x is equal to 49 upon 29 and y is equal to 19 upon 29, what you can do is you can take the starting two equations and put the value of x and y and see whether the equation holds true or not. And that is exactly what we have done in verification. The first equation was 7x minus 15y is equal to 2. If we have put x as 49 upon 29 and y as 19 upon 29, and we do get 2 is equal to 2, which is correct. And in the second equation, we have put x and y here and we get 3 is equal to 3, which means our solution is correct. So whenever you are in doubt that whether the value of your x and y or the solution of the linear equations is correct or not, just put them in either of the equations, and if the equation holds true, that means you've got the correct solution, right? Now this was a substitution method. You might think that this is a little longer method. So now let's move on to the shorter method, which is the elimination method. So with the name elimination, you must understand that what we'll try to do is we'll try to eliminate one variable from the equation. So let's take this example where the first equation is 9x minus 4y is equal to 2000 and 7x minus 3y is equal to 2000. This is the second equation. So now what we will trying to do is, you can choose any, you either choose x or you choose y. We'll try to eliminate either of these variables. Now, how do we do that? What we do is the coefficient of either of the variable or the constant, you can call it constant, we try to make it equal. Here, say for example, we choose y, right? So here we have 4y and here we have 3y, right? So how do we make them equal, right? If I multiply 3 in equation 1 and I multiplied 4 in equation 2, we would get 12y in both, right? So that is exactly what we have done in first step. We have multiplied 3 in equation 1 and 4 in equation 2, which brings us this. 27x minus 12y is equal to 6000 and 28x minus 12y is equal to 8000. Now we've gotten another equations. Let's name them 3 and 4. Right. Now what we will do, we will subtract equation 3 from equation 4. Right, we would subtract equation 3 from equation 4, which would give us 28 minus 12y, this is from equation 4, minus 27x minus 12y, this from equation 3, and 8000 minus 6000, right? We're just subtracting these together. So in this, if we say what we did, right, we made their coefficient equal. So this is where it would help. The coefficient, the values with y would cancel each other out. This is why it is called elimination method, because we've eliminated the y variable from the equation. So now it gives us 28x minus 27x is equal to 2000, right? So this is linear equation in one variable, right? So we get x is equal to 2000 from this. Easy. Now, in the previous substitution method, what we did, when we found out the value of y, we put it in any of the equation and we got the value of x. And the same way we are doing it here. We are putting the value of x as 2000 in the equation and getting the value of y as 4000. Right. So now we have x is equal to 2000 and y is equal to 4000, which is the solution of the linear equations. Now, just to check whether we have got the right solution or not, what we do is, this is the equation 1, this is the equation 2. We substitute x is equal to 2000 and y is equal to 4000 here, and we get 2000 is equal to 2000, which means it satisfies LHS equal to RHS. And in this, when we put x is equal to 2000 and y is equal to 4000, we also get 2000. That means LHS is equal to RHS. Hence, x is equal to 2000 and y is equal to 4000 are our solution for these two linear equations in two variables. So this was the elimination method. Now we have some questions. Try doing these questions with both. First, try to do them with elimination method, then try to do them with substitution method with proper naming and writing the number of equations and everything. So hope you like this video. Thank you.